to another Daishinfinity video. In this video we're going to talk about the Thales Theorem, which is not so common in America or in general English speaking countries, schools, educations. Is a very popular proof from Thales, which states that if we have a diameter AB and if we put another point C on a semicircle, we would get a right triangle, and the right angle would be at the point C. The point C is over here. I'm going to write the point C over here. Now I would like to prove this by using linear algebra, by using some kind of vectors and using properties of the linear algebra theorems. So let's construct the triangle again. I'm going to call this point M, this point A, this point B, and another point C on a semicircle. So C is just an element of the circle. O, I'm just going to call it O. Now A, M is the same as MB or BM, I don't care, and is also same as MC or CM, I don't really care, which is going to be the radius of the circle. So these are two properties we have. We're going to connect these points. Now the secret about this is we're going to use vectors. So it's going to be pretty interesting because if we use vectors, we can use some properties of the linear algebra theorem. So let's call the vector from M to A minus U1. And the vector from M to B, I'm going to call it U1. Okay, this is a very weird looking U. This is what I learned in a German linear algebra book. They have these kind of vector notation. So I'm going to use this notation as an example. Now the vector from M to C is going to be called, let's say, U2. And the vector, let's say, I'm going to use blue. This is going to be U, and this is going to be B. So now we have U equaling AC, B equaling oh, sorry, I didn't write the directions, so this is going to be BC. U2 is going to be MC. Minus U1 is going to be MA, and U1 is going to be MB. Now since we have all the information and we state that the angles between U and B is the same, we can also state that U times B is equal to 0 is the scalar product between these two vectors. Now if you look at the map again of the triangle, we can say that minus U1 plus U, okay, is equal to U2, is this one. We can also state that U1 plus B is the same U2. So we can write two equations. I'm going to write them over here. That U2 is equal to minus U1 plus U, and that U2 is also equal to U1 plus B. Now we can subtract U2 on both sides of the equation. We can call it 1 or 2, but we're going to do it in another way. I'm going to let U and B be the variable. So we're going to say that U is going to be U2, and adding U1 on both sides, we'll get plus U1. Now B is going to be, instead of U2 plus U1, is going to be U2 minus U1, because we know that we have to subtract U1 on both sides. Now since we stated that U times B is equal to 0, we can just plug in these things and say that U2 plus U1 times U2 minus U1 is equal to 0, which means that U2 plus U1 is equal to 0, or U2 minus U1 is equal to 0. Well, I'm going to do that in a second. Well, I would like to use the distributive rule to distribute the parentheses, which would mean that we would have the third binomial theorem stating that 0 is equal to u2 square minus u1 square. Now, if we square a vector, it means that I'm going to take the scalar product of the same vector 2 times. Now, what does it mean to take the scalar product of the vector? Let's first state the scalar product, the definition of it. If we have a vector a and b and an angle alpha, it will mean that the scalar product a times b is equal to cosine of alpha times the length of a times the length of b. Now, if a is the same, a times a, which would mean that the angle between these two vectors is 0, and we would take the length on both sides, which would mean I would have some kind of an area of a square, which is pretty interesting. Now, cosine of 0 is 1, so we would just get that a times a is equal to the absolute value of a squared. Okay, so using that property for my u2 and my u1, it would just mean that we would get u times b is equal to 0 is equal to the absolute value of u2 squared minus the absolute value of u1 squared. Now, we stated that this should be 0, so we can add u1 on both sides, square it, and this one is also square. Take the positive branch of the square root, we would get that u1 has to be equal to u2. Now, if we look at the triangle, we see that the length of u1 and the length of u2 are the radius of the circle. So if they are not the same, it will not become a part of the radius. So the u1 and the u2 should be same. If that is the case, then we can say that u times b, the scalar product of these two, which will be 0, okay? Which states that we have proven this theorem, and we have proven that AC is perpendicular to CB. Okay, you can also call it CA or BC, I don't really care. And yeah, this is the end of the video. I hope you like this video. If you like, please comment and subscribe to my channel, and we'll see us in the next Daishinfinity video. See ya.